Today in Algebra 1 we talked about powers and exponents. So the title is Powers and Exponents. And this should mostly be a review from your previous pre-algebra class. We have a definition for the word power, and that is an expression with an exponent and a base. For example, if I look at 3 to the second, the 3 is the base and the 2 is the exponent. And technically the whole thing, 3 to the second, is called the power. Now, math teachers and people in general will often say 3 to the second power, and that's not necessarily incorrect, but sometimes we get that confused because that sounds kind of interchangeable, those words power and exponent. Some examples we used that dealt with geometry were things that were 2D or 3D. For example, number 1, if I draw this right here, that little shape with those dots, you'll notice that I have 3 by 3, 3 rows by 3 columns. And you'll see that the 3 is written twice. It's a 2D object, so that's 3 squared, which is equal to 9. That's how I write it as a power, and 9 gives me the answer of how many dots I have. Also, if I wanted to look at another shape, maybe a 3D object, could look at a box or a cube. If I said that 4 inches were on each side, then 4 would be my base because that's how large each side is. And then I would do the length times the width times the height, which is 3 dimensions. Length, width, height. I would write that 4 times. My base is 4, and I raise that to the third power. And if I worked that out, I would get 4 times 4 to be 16, times 4 to be 64 inches cubed. Some other applications we talked about was when we were reading, how we would read and write these words and symbols. For example, and I'm going to kind of shorten this, when you see the notes that I've printed for you, you'll see that we did a few more examples. But if I did 3 to the first and 3 to the second only, I would say this, 3 to the first power. And I would say this one, 3 to the second, or 3 squared. If I wrote it, there would just be 1 3 here, and the value would be 3. Right here, I would say 3 times 3, and the value would be 9. And if I wanted to continue that, I would have the special names 3 to the third or 3 cubed, write it 3 times, and that would be 27. Or 3 to the fourth, which does not have a special name, nor does anything from that power on. I would write it 4 times, and 3 to the fourth power is equal to 81. Some other things that we talked about today in class. In example 3, we talked about negatives. So negative 2 to the third power. My base here is negative 2, and I know that because it's inside the parentheses. The order of operations tells me to do parentheses and then exponents. So I'm going to take this parentheses negative 2 and write it 3 times. And when I do that, negative 2 times negative 2 is 4 times negative 2 is negative 8, and that is my answer. Let's look at a different type, negative 2 squared. This time I do not have the parentheses, which means instead of my base being negative 2, it's simply 2 due to the order of operations. The order of operations tells me to do parentheses and then exponents. So if I'm doing exponents next, I would do 2 squared, or 2 times 2. And then I would add the subtraction back on at the end, just one subtraction sign, because that's dealing with the negative. Negative 2 times 2 is negative 4. Now, think about if I would have had this in parentheses. Negative 2 squared in parentheses is negative 2 times negative 2, which would yield an answer of 4. Negative 4 and 4 are not the same, so you'll want to watch out for parentheses and negatives when you're doing powers and exponents. Let's look at one that has a fraction. For example, number 5, 2 thirds to the fifth power. The fifth power tells me I write each piece 5 times. So 2 times 2 times 2 times 2 times 2 over 3 times 3 times 3 times 3 times 3. And 2 to the fifth power is 32, and 3 to the fifth power is 243. If you don't have a calculator handy, you'll just have to work that out to the side For example, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. In general, if you want to reduce your fraction, that would be a good idea, but that one is already reduced as far as it can go, so we're not going to worry about that from there. The last thing I want to show you in example 6 is what to do if they give you something like 8 and then semicolon base 2. And what we're doing here is they're telling us what the base is, so we're going to write 2, and then we need to figure out what exponent we want to get us back to 8. We can't do anything to the 2. That has to be our base. So we could do 2 to the first power, which would be 2. That's not 8. 2 to the second power would be 4, because that's 2 times 2. That's not 8. 2 to the third power. 2 times 2 is 4, times 2 is 8. So that's our answer, 2 to the third power. And that's what we learned today in Algebra 1. If you have questions, be sure to come to tutorials.